Hi all, a warm welcome to all the students who are listening to this class. In this session, we are going to discuss a very important topic for many competitive examinations, boards and streams. As you can see on the screen, this is the topic what we are going to discuss today on boards and streams, and we will solve some extraordinary questions in this particular topic, ranging from basic level to intermediate to advanced level questions also. But before starting solving our problems, let us always understand the concept behind solving the questions on boards and streams. What is required to solve questions on this particular topic, we will analyze first, and then we will move on to problem solving in the next few minutes of our time. Now, before I start problem solving, first I will explain you the very basic concept of boards and streams. This is something which I have also explained in time, speed and distance topic. When I have taken time, speed and distance, you can refer to that video. When I have taken AM/HM, that means arithmetic mean and harmonic mean topic, I have explained a similar concept there also. Once again, I want to revisit for a couple of minutes so that we will understand it once again and then start solving problems on boards and streams. Now, first thing is, suppose there is a water flowing in this direction with a speed of W, and there is also a boat which is moving in the same direction with a speed of B. Water and both are in the same direction. That means water, because it is in the same direction as that of the boat, it is helping the boat to reach the destination faster. Forget about faster or slower. Basically, it is helping the boat to reach the destination. So, because water is helping the boat to reach the required destination, the total speed of this particular scenario, which is case 1, is it is B plus W, right? It is B plus W. Case 2, I will explain you the second scenario. There is a scenario where water is flowing in the opposite direction to that of the direction of the boat. That means boat is trying to move in the direction which is directed in the diagram. Water is actually flowing in the opposite direction. Because water is flowing in the opposite direction to that of water, the water will try to retard the speed of boat. That means it will actually pull the boat towards itself as much as possible, and thereby boat will also reach the destination in this case also, but it will be little slower to reach the destination. So, because water is actually hindering the speed of boat in this case, the speed is B minus W, right? The speed is B minus W. And the last case is the water is not at all flowing. That means the speed of water is almost negligible. I will assume it as 0. Such kind of speed or such kind of things, we call it as still water. That means water is just still there. It is stagnant. It's not moving. Boat is alone trying to reach the destination with its speed alone. So that is nothing but B plus water. B plus 0 is nothing but B. That means B plus W is nothing but the speed of boat and water when both of them are moving in the same direction. B minus W is nothing but the speed when both boat and water are moving in the opposite direction. If I take only B is nothing but the speed of a boat. It is in still water, right? B is nothing but the speed of boat in still water. That means whenever boat and water are moving in the same direction, that kind of speed, we call it as a downstream speed, right? The terminologies are very important in boats and stream topic. Downstream speed, I will represent downstream speed as capital letter D. Don't get confused with capital letter D as a distance, which I took it in time, speed and distance. Please do not get confused. In this particular topic, I will probably use always capital D as a downstream speed. And downstream speed is nothing but B plus W. When both boat and water are moving in the opposite direction, we generally call it as upstream speed, right? We generally call it as upstream speed. Upstream speed, I will represent it as capital U, and that is nothing but B minus W. So in simple language, downstream speed is nothing but B plus W. Upstream speed is nothing but B minus W. Then what is this B alone? B is nothing but, it is nothing but the speed of boat, right? It is nothing but the speed of boat. But is there any specific scenario for the speed of boat? Yes. B is nothing but speed of boat in still water. You can see that I have taken third case where it is in still water. So in simple language, downstream speed is b plus w, upstream speed is b minus w, and b is nothing but the speed of boat in still water. Then what is this w? W is nothing but the speed of water current, right? It is nothing but the speed of water current, or generally they will call it as speed of water, or they can call it as speed of current. Every terminology is the same. The W is nothing but the speed of stream, that also can be used. There are so many terminologies which will come in this particular topic. We will keep on seeing it as we proceed with more and more problem. But I think that the beautiful concept is very, very clear for all the students who are listening to the class. I will just write it in nutshell in my next screen. Downstream speed is nothing but b plus w. Upstream speed is nothing but b minus w. But we will not end this with this particular thing. We will also calculate a few more parameters here. Now, if I continue solving this equation, plus w and minus w will get cancelled. B plus b is nothing but 2b. So right hand side is 2b, left hand side is d plus u. So can I say that b is nothing but d plus u by 2. D plus u by 2 is nothing but b. And I already told what is the meaning of b. B is nothing but speed of boat in still water, right? B is nothing but speed of boat in still water. Similarly, if I want to find what will be the value for w, subtract it. That means change the sign in the below equation. If I change the signs, minus b and plus b will cancel in this case. W plus w will become 2w, and the left hand side will be d minus w. D minus u. So w will be equal to d minus u by 2. So very, very important 4 equations that we need to know in this particular topic. I am very, very concerned about these 4 equations, and that is the reason I am taking little bit of extra time to explain you these 4 equations, because we keep on using these 4 equations in almost every problem what we solve. So I repeat once again, file and time. Downstream speed is b plus w, upstream speed is b minus w. B is nothing but the speed of boat in still water, which is nothing but d plus u by 2, which I gave you the proof also. And w is nothing but d minus u by 2, and w is nothing but speed of water current, or speed of water, or speed of current, or speed of stream. There are so many terminologies, is what I said already. I hope you are very, very clear with these 4 equations, whatever we have taken till this particular time. Now, before I move forward, I also wanted to just give you a small glimpse of these terminologies. Now see here, don't get too much confused with whatever I am trying to say. It's very simple. Downstream speed, see, it's something like suppose you take a very, very simple scenario of our day-to-day life. Suppose, for example, we are traveling in a two-wheeler or whatever the vehicle. So downstream speed is nothing but basically when we are traveling down. Suppose generally we travel in a straight road. Suddenly we got a road which is little down. So whatever the speed that we apply, or whatever the speed at which we go, that generally is called as downstream speed. So I am just giving a small idea for you people to understand it better, so that you will not get confused. Suppose upstream speed. Suppose while traveling in a straight road, we get an up road. We get a road which is slightly inclined, which is an up road. Whatever the speed at which we go in that up road is generally termed as an upstream speed. So basically, up and down are opposites of each other. Same is the case here also. Upstream speed and downstream speeds will definitely be opposite to each other. Now think little logically. You will only say something to me. Whenever we are going down the road, or whenever we are going up the road, whether we are going down the road or whether we are going up the road, which speed will be faster? Whenever we are going down, is it faster, or whenever we are going up, is it faster? Whenever we are going down, the speed will always be faster. That means downstream speed will always be faster or greater than the upstream speed. So one more important notation is downstream speed will always be greater than the upstream speed. These are all something which I will definitely use in problem solving. That is the reason I am making sure that all these things are very, very clear for my students at the beginning of the class itself. Now, downstream speed is greater than upstream speed is something we understood. And similarly, can I say that whatever the speed of a boat in still water, that means when the water is not at all flowing, it's a still water, whatever the speed of boat will be there, that will always be greater than the speed of water current. Water current speed will always be lesser than the speed of boat in still water, or speed of boat in still water will always be greater than speed of water current. So if I combine these two equations, generally you will get an equation like this. Downstream speed will always be greater than speed of boat in still water. That will always be greater than upstream speed, and upstream speed will always be greater than water current speed. You will understand this equation as we proceed with problems. You can verify or whether this is true or not in our upcoming problems also. Definitely, for sure, you can verify whether this condition is satisfying or not. But I just wanted to give a basic idea before I start solving problem. That is the reason I explained at the starting of the concept itself. In the conceptual clarity itself, I want you people to be very, very clear about it. Now, I hoping that you are clear with concept, whatever we have thought or whatever we have learned using the 4 equations, whatever we have understood, and also the beautiful things are nothing but here is nothing but the terminologies we should definitely know about. Hoping that you are all clear with the terminologies and other things. We will start with our first problem, and that will be the basic problem. We'll start with very, very easy question, and slowly we will probably scale up the level of difficulty. Now see here, first question is, a boat covers a certain distance downstream with a speed of 33 kilometers per hour. That means downstream speed D is given as 33 kilometers per hour, and upstream at the speed of 14 kilometers per hour. Upstream speed is nothing but it is 14 kilometers per hour. So I came to know the value of D. I also came to know the value of U. Now the next thing is, then find the speed of boat in still water. Speed of boat in still water is nothing but B, and also the speed of current. Speed of current is nothing but W. Now it's a very, very basic question, because we know that speed of boat in still water is D plus U by 2. 33 plus 14 is 47. 47 divided by 2. It is 23.5 kilometers per hour. If you observe the answer options, there is only one option which is having 23.5 kilometers per hour. So you can eliminate the other options. The answer should be option B. But just to cross check whether your answer is right or wrong, please also find the speed of water current. It is D minus U by 2. 33 minus 14. 33 minus 14 is nothing but 19. 19 by 2 is 9.5 kilometers per hour. So answer for this question is option B, which is 23.5 kilometers per hour and 9.5 kilometers per hour. But I generally do not want my students to solve it in this way, given the answer options also in the examination. Suppose assume that these are the answer options given. Yes, whatever the way you solved is beautiful, sir. It's a very, very generic method. You use this method of B is equal to D plus U by 2, W is equal to D minus U by 2. Absolutely fine. You have substituted, simplified. Everything is beautiful. You got the answer. Beautiful. Now see here. Suppose, for example, I do not want to solve like this. I will just try to solve it without using this. If it is really not happening to solve it in a different method, then I'll come back to this for sure. Now let us try it out. Let us try to eliminate as many answer options as possible. In case if I could eliminate 3 answer options out of 4, the other one will be the definite right answer. Right? That is very, very basic common sense that everyone is definitely aware of. Let us try it out. If at all I am not able to eliminate 3 out of 4 answer options, then definitely this is the method. Whatever we have solved already will be very handy. Now see here, think little logically. We already know that speed of boat in still water will always be greater than speed of water current. I just discussed this concept before solving the first problem in boats and streams. So B is greater than W, and the options are like first option, first value is the speed of boat in still water, second value is speed of water current. That means 9.5 is not greater than 23.5. Answer option A is definitely ruled out. 4.5 is not greater than 28.5. Answer option D is definitely ruled out. So in option B and option C, there are cases where first value is greater than second value. So we really don't know which is correct out of that. That is the reason we used this method. In case if there is another possibility where we could eliminate option C also in some other method, then you don't need to apply B is equal to D plus U by 2 also. So what I am trying to say is, do not always jump to the conclusion of substituting and simplifying by variables or formulas. Try to be little smarter and try to solve it in a smarter approach. If it is not at all possible, come back to the traditional method. I hope the first basic problem is very, very clear for you people. Second one. Second question. We will solve some easy questions initially, just not that one or two basic questions. I will take some basic questions, then I will come back to my original questions. Now see here. Second question. A boat moves downstream at the rate of 1 kilometer in 7.5 minutes. That means they are saying that downstream they are talking about. First, let me write it for your better understanding. Let me not confuse you people. We are discussing a concept of downstream at the first statement. What is that they are saying? They are saying that at the rate of 1 kilometer in 7.5 minutes. That means in 7.5 minutes, it is like a person or a boat is able to travel 1 kilometer. But we generally want to convert it to 60 minutes. 7.5 into 2 is nothing but 15. 15 into 4 is nothing but 60. I hope you are understanding how I found out the multiplying factor as 8. So basically 7.5 into 8 is 60 minutes. 1 also multiply by the same multiplying factor 8. So it is 8 kilometers. So what is the meaning of this? That means a boat in 60 minutes. In 60 minutes, a boat can travel 8 kilometers. So 60 minutes is something which we already know as 1 hour. So downstream speed D is nothing but 8 kilometer per hour, right? 60 minutes is 1 hour. 8 kilometer per hour. Indirectly they are giving in the second question. They are not giving directly like the way they have given in the first question. I hope you are understanding the difference between first and second question. Now, upstream at the rate of 5 kilometer an hour. So directly they have given the upstream speed as 5 kilometers per hour. So what is the speed of boat in still water is the question. So B is nothing but D plus U by 2. It is 8 plus 5 by 2. It is 13 by 2. Answer is 6.5 kilometers per hour. So answer for this question is also option B, which is 6.5 kilometers per hour. Now, thinking little logically, I already told you generally probably don't need to apply B is equal to D plus U by 2 and other cases. If you think little logically, now see here, how can I think little logically in this case? Let us analyze this in this small box towards the bottom right corner. Now think logically. We know that speed of boat in still water is always greater than the upstream speed, right? Upstream speed. Now what is the question they have asked? In the question they have asked you to find the value of capital B, speed of boat in still water, and upstream speed is given in the question as 5 kilometers per hour. So that means speed of boat should be greater than 5. So answer option 4 and answer options C and D are eliminated because C and D are lesser than 5 kilometers per hour. So directly you are eliminating 2 options out of 4 options using this beautiful condition. Now we also have one more condition. That condition is downstream speed is always greater than the speed of boat in still water. So downstream speed is always greater than speed of boat in still water. So can I say that I am trying to find the speed of boat in still water right now, and downstream speed is given in the question as 8. So 8 is greater than B, or B should be less than 8. So there are only 2 options left right now, and B should be less than 8. But first option is not less than 8. First option is equal to 8. So first option is also ruled out. Therefore, the second option should be the right answer. I hope you are understanding a beautiful conceptual way of problem solving without using B is equal to D plus U by 2. Yes, I have used that also and I have solved it. I am not saying I did not use it, but I am saying you can still neglect using that. You can still avoid using it and try to solve it by using a very, very beautiful conceptual way of problem solving. It's all about thinking. If you think smart, I think you will ink smart. As simple as that. I hope you are clear with the concept in the second problem. Next. Question number 3. Question number 3. Third question says, a boat covers 93 kilometers downstream in 4.5 hours. So downstream speed, which I generally call it as D, it is. So we know that speed is equal to distance by time. Distance is given as 93 kilometers. Time is 4.5 hours. So 4.5 is nothing but 9 by 2. That by 2 will go above. I hope you are understanding. I am explaining very, very slow because the basic idea is to make you people understand, not just explain whatever I know. Now, if I simplify further, 3 into 3 is 9. So 3 into 31 is 93. 31 into 2 is 62. 62 divided by 3 kilometers per hour will be the downstream speed. Next, whereas 105 kilometer upstream in 6 hours and 18 minutes. Now, first thing that we need to do is we need to convert 6 hours 18 minutes to completely hours. 18 minutes. If I want to convert it to hours, it is 18 by 60 hours. So 6 into 3 is 18, 6 into 10 is 60. So it is 6 hours and 3 by 10 hours. It is 6 3 by 10 hours. I hope you are understanding. It is 6 3 by 10 hours, or in other words, mixed fraction convert to improper. It is 63 by 10 hours. So upstream speed U is nothing but distance upstream is 105 kilometers given in the question, and time is 63 by 10. 63 write it here, 10 write it above. So if I further simplify this also, this is 21 into 3, this is 21 into 5, 5 into 10 is 50 divided by 3 kilometers per hour. And what is that they are saying, asking in the question, find the speed of water current. So we know that speed of water current is, it is nothing but D minus U by 2, or you can use that other conceptual way of solving also, which I thought it. But if you see the answer options, all the options are very, very close to each other. They are just having a difference of 0.5 kilometers per hour between them. So generally we will not try to apply that conceptual way what we used in our previous problem. So directly calculate. Anyway, it's not very difficult to calculate. So D minus U, D is 62 by 3 minus 50 by 3. 62 by 3 minus 50 by 3 is 12 by 3. 12 by 3 is 4. 4 divided by 2. It is 2 kilometers per hour. Answer for this third question, which is a still basic question. I am not saying that I have moved on to next level questions yet. I am still in basic level questions because I want to give you ample amount of clarity in the basic questions before I move on to the next level questions, so that it will be super clear for all my students listening to the class. I hope the first 3 questions along with the conceptual clarity is very, very clear for you people. Fourth question, question number 4. Again, it's a very easy question if you just understand it. The speed of boat in still water is 27 kilometers per hour. So B is given as 27 kilometers per hour. It covers upstream a distance of 85 kilometers in 4 hours 15 minutes. So 4 hours 15 minutes is nothing but 15 by 60 hours. So 4 15 by 60, it is 1 by 4. 4 1 by 4 is nothing but 17 by 4 hours. I hope you are understanding. So upstream speed is nothing but distance is nothing but 85. Time is nothing but 17 divided by 4. That divided by 4 will come above. 17 into 1, 17 into 5. 5 into 4 is 20 kilometers per hour. So what is that they are asking you in the question? The speed of water current or water stream is how much? So we know that upstream speed is nothing but B minus W. So upstream speed is 20 and B value is 27. 27 minus which number is 20? 27 minus 7 is only 20, and that is what we require in this question also. These are all very basic question. Again, I am repeating, my intention is to make you clear with the concepts before I move on to some beautiful questions in boards and streams. And trust me, it is one of the most important topic in many competitive examinations. Next question says, the speed of boat in upstream is 30.6 kilometers per hour. Upstream speed is 30.6 kilometers per hour. But the speed of current is, that means current is nothing but water. It is 4.5 meters per second. Now, first unit is kilometers per hour. Second unit is meters per second. I don't like it. Generally, you also don't like it for sure. Convert both of them to any one of them. So generally, we will always convert it to kilometers per hour. So why kilometers per hour? Can I convert both of them to meters per second? Absolutely, you can convert. But see the answer options. Answer options are in hours. So generally, it's advisable to convert this also to kilometers per hour. How will you convert meters per second into kilometers per hour? It's again a basic concept. Multiply that by 18 by 5, right? 18 by 5. I will just erase it if you are getting confused, or if you are not getting confused, let it be, sir, right? So multiply it by 18 by 5. 4.5 into 18 by 5. If you want to convert from meters per second to kilometers per hour, multiply the meters per second value by 18 by 5. The reverse is, if you want to convert kilometers per hour to meters per second, multiply the kilometers per hour value by 5 by 18. So 5 into 1. 5 into 9 is 45, but it is 4.5. So it is 5 into 0.9. So 18 into 9 is 162, but it is 0.9. So it should be 16.2. So speed of water current is 4.5 meters per second, or it is also true, it is 16.2 kilometers per hour. Both are absolutely same. Now what is that they are asking? Find the time taken by the boat to cover a distance of 210 kilometers downstream. That means we know the concept as distance is equal to speed is equal to distance by time, right? Speed is equal to distance by time. Distance is equal to speed into time, right? Distance is equal to speed into time. Now think little logically here. What is that they are asking you in this question? They are asking you find the time taken by the boat to cover a distance of 210 kilometer downstream. So downstream distance is given in the question as 210. No doubt about it. Downstream distance is already given in the question. Downstream speed, we don't know what is the downstream speed. Upstream speed is given in the question as 30.6, but they have never given you the value of downstream speed. That is something we need to calculate. Into downstream time. Is downstream time given? No. Downstream time is something that we need to find it. So let us keep it. Downstream speed, I will call it as D, and downstream time, I will call it as TD. TD refers to downstream time. Please don't get confused. This is the distance I am writing in complete words. D is nothing but downstream speed. Don't get confused with capital D as a distance. D in this entire boats and streams, capital D refers to downstream distance, downstream speed, right? I hope you're having clarity and you are not getting confused with that. Now see here, I don't know what is the downstream speed. Now can I say that I know upstream speed value and I also know the value of W? So using this, can I say that upstream speed is nothing but B minus W? Upstream speed is 30.6. B value I don't know, minus W value is 16.2. So B value will be 30.6 plus 16.2. It will be 46.8 kilometers per hour. Now you might suddenly get a doubt. Why are you calculating B value, sir? I am not interested in B value. I am interested in downstream speed, that is D value. Now, if you want to calculate downstream speed, that is D value, downstream speed is nothing but B plus W. And we were not knowing the value of B earlier. That is the exact reason I calculated now. I hope you are getting the clarity why I calculated B value initially. So it is 46.8 plus W value is 16.2. So 46 plus 16 is 64. 0.8 plus 0.2 is 1. So downstream speed is 65 kilometers per hour, right? Sorry, 46 plus 16 is 62, right? Not 64. I'm sorry for that. 46 plus 16 is 62 plus 0.8 plus 0.2 is 1. It is 63 kilometers per hour is the downstream speed. Now, can I say that I know the downstream speed? I know the distance also. So time taken to travel downstream is, it is 210 divided by 63 kilometers per hour. So if I further simplify, just for your simplification purpose, 210 divided by 63 is nothing but 21 into 3. 21 into 1, 21 into 10. So it is 10 by 3 hours. 10 by 3 hours can be further calculated as mixed fraction 3 1 by 3 hours. So this is 3 hours, but unfortunately all the 4 options are 3 hours only. 1 by 3 hours. If I want to convert hours into minutes, multiply 1 by 3 by 60. 1 by 3 into 60 is nothing but 20. So it is 3 hours and 20 minutes. Answer for this question is 3 hours and 20 minutes. So this should be option A. So answer for this question is 3 hours and 20 minutes. I hope this question is very, very clear for you. Next question. Beautiful question. Extremely beautiful question. Please keep on listening to this question and the upcoming questions very carefully for your better understanding. The question says, the speed of boat in still water is 25 kilometers per hour. That means, let me write the data whatever is given. B value is 25 kilometers per hour and the speed of current is 7 kilometers per hour. W value is 7 kilometers per hour. I hope this data is clear for everyone. Now, forget about the next part of the question. What all we can find from this? So we can find downstream speed. It is B plus W. 25 plus 7 is 42 kilometers per hour. 32 kilometers per hour. I don't know why am I making too much of mistakes. So every now and then. So I hope you are able to see it properly. I don't know why am I not. Yeah, I got the eraser right now. So I'm sorry, sir. Just give me a second. Yes, so 25 plus 7 is 32 kilometers per hour and W also, not W once again. So it is D we calculated and we can also calculate upstream speed. Upstream speed is nothing but U. So U is nothing but 25 minus 7. It is 18 kilometers per hour. This can be calculated very easily from the first statement what is given. Now read the next statement. If a boat goes from place A to B and return from B to A, that means a boat is traveling from A to B, right? A boat is traveling from A to B and it is returning from B to A. A boat is traveling like this from A to B and it is returning from B to A once again. So that is what is given in the statement and it takes 6 hours and 40 minutes in total. So total time taken to travel from A to B and return from B to A, it is given in the question as 6 hours 40 minutes. So 6 hours is 1 hour is 60 minutes. 6 hours is 60 into 6. It is 360 minutes plus another 40 minutes. So total time taken is 360 plus 40. It is 400 minutes. I will just keep it here. Let me see if this data is useful at some time. Let us see later. Now, what is the question? Find the time taken by the boat to cover twice the distance of AB downstream. That means, see, think little logically, sir. This is traveling, a boat is traveling from A to B initially. Suppose, assume that from A to B it is downstream. If I am going in a particular road down initially, if I want to come back in the same road once again, the road will become up, right? It will be a up road. So that means if I am traveling from A to B as a downstream, so from B to A, it is considered as upstream. I hope you got the logic. So what is the question? If I am traveling from A to B as downstream and B to A as upstream, total time taken is 400 minutes. No doubt it is given in the question itself. But the question says, find the time taken by the boat to cover twice the distance of AB. That means the same distance it should cover 2 times, but it should cover downstream only both the times. So you might think logically, how can I go both the times are down only, sir? Is it possible logically thinking also? No, it is not possible. So what they are actually asking is, calculate how much time it is taking to go down the lane only once and double that value finally. Double that time value. That's all. You don't need to worry about too much about it. I hope you are getting the logic. Now see here. The best way to solve this question is through ratio. That is the reason ratios is considered as one of the powerful technique in the world of aptitude. Now see here. The best way to solve it through ratios. Now can I say that downstream speed and upstream speed? So I don't know why am I writing upstream speed as W always. It is U. Don't get confused once again. I'm so sorry for that. Downstream speed is to upstream speed. The ratio is 32 is to 18. The ratio is 32 is to 18. 32 is to 18 is 16 is to 9. Now, can I say that a boat is traveling from A to B and the boat is coming back from B to A? The distance is constant. The distance is constant. Distance is not changing. The distance from A to B and the distance from B to A is constant. So the speed ratio from down to up is 16 is to 9 and the distance is constant. If the distance is constant, speed and time are inversely proportional to each other. If the speed ratio is 16 is to 9, the time ratio will be reverse of 16 is to 9. It is 9 is to 16. That means according to the ratio, if I go down the lane from A to B, I will just take 9 minutes to travel according to ratio. If I come back from B to A in a upper way, I will take 16 minutes to travel from B to A in the upper way. So total time taken according to the ratio is 9 plus 16 in both the directions of down and upstream. I hope you are understanding. Total time taken according to the ratio is 9 plus 16, which is 25 minutes. But the question says, no, both the ways it is not 25 minutes according to the question. It is 400 minutes. So 25 should become 400. 25 into 4 is 100. 100 into 4 is 400. So 25 into 16 is 400. Now what is the question? Question is, find the time taken by the boat to cover twice the distance of AB downstream. So downstream time according to ratio, downstream time is 9 minutes. Multiply this 9 also by 16. 9 into 16 is 144 minutes. But think logically, in a hurry, don't mark the answer as 144 minutes because this 144 minutes is only for one time of downstream distance. But the question says, time taken by the boat to cover twice the distance. If you are covering one time of distance of AB in 144 minutes, then 2 times it should be 2 times of 144 minutes. So it is 288 minutes. 288 minutes is 240 minutes plus 48 minutes. 240 minutes is 4 hours. Answer for this beautiful question, which can be solved beautifully in fact using the concept of ratios, is 4 hours and 48 minutes. I hope every student is very clear with the concept that is being taught in solving this problem. I hope the concept is very clear for you people. Next question. Now, before solving the next question, which is taken in boats and stream, I want to take one question which I have solved in trains. When I took trains topic, I have solved this similar question. I want to revisit that question once again quickly so that you will understand. And the similar concept I will apply for boats also. It really does not make any difference, sir. Instead of train is one object, boat is another similar object. Replace the train by boats. It becomes a question on boats and ship. That's all you can say, right? Now see here. Suppose a train is traveling from A to B. A train is starting at 8 o'clock in the morning. It is traveling from A to B. It is reaching point B at 12 noon, for example. There is another train which is present at point B. That is also starting at the same time 8 o'clock in the morning. No change in the starting time of both the trains. And this is reaching point A at 2 p.m. Now my simple question is, when they are traveling in the opposite direction like this, first train is starting from A and it is reaching B, second train is starting from B and it is reaching A. When they are traveling in the opposite direction, at some point both the trains will meet, right? At some point, suppose this is the meeting point, for example. My question is, at what time will they meet is the question, right? At what time will they meet? And if you are very clear about trains topic what we have taken, you would have already got the answer by now, because it's a very beautiful concept what we have applied in trains. Why am I taking once again? Because I want to connect the dots between this train topic to the topic what we have in boats and streams. That is the reason I am revisiting once again. Now see here, time taken by the train to travel from A to B, 8 o'clock to 12 noon, it is 4 hours. Time taken by another train to travel from B to A, 8 o'clock to 2 p.m., it is 6 hours. I know that the distance from A to B is constant. Because the distance is constant, I can assume the distance as LCM of the given times, right? Why am I taking the LCM? All these things, please refer to my time, speed and distance topic. You will understand it much more beautifully. LCM of 4 and 6 is 12. So I will assume the distance between A and B as 12 kilometers. I am assuming the distance as 12 kilometers. Now see here, if the distance is 12 kilometers, if the distance between A and B is 12 kilometers, and we know that we need to find the meeting time. We know that time is nothing but distance by speed, right? Speed is equal to distance by time. Time is nothing but distance by speed. Now, can I say that distance, suppose for example, A has traveled a little distance, B has traveled a little distance. A came to this point M here. B also would have come to this point M. That is the reason they are meeting at this point right now. So can I say that total distance traveled by both A and B together is nothing but 12 kilometers. If A has traveled 2 kilometers, B would have traveled 10. If A has traveled 3 kilometers, B would have traveled 9. So totally it should be 12. So it should be 12 divided by, whenever two bodies are moving in the opposite directions, relative speed is nothing but the sum of the speeds. So, but before that, we don't know the speed of these two. Let us calculate speed. Speed of first train A, it is distance by time. Distance is 12, time is 4. 12 by 4 is 3 kilometers per hour. Speed of the second train B is distance by time. Distance is 12 and time is nothing but 6 hours. 12 by 6 is 2 kilometers per hour. So first train is actually traveling at 3 kilometers per hour. Second train is traveling at 2 kilometers per hour speed. So relative speed when they are traveling in opposite direction is, it is 3 plus 2. So it is 12 divided by 5. 12 by 5 is nothing but 2 by 5 hours. 2 by 5 hours is 2 hours, and 2 by 5 hours is multiply 2 by 5 by 60. So if I multiply 2 by 5 by 60, I will get 24 minutes. That means after 8 o'clock, they will travel for 2 hours and 24 minutes. After 8 o'clock, if they are traveling for 2 hours and 24 minutes, what will be the meeting time? 8 o'clock plus 2 hours 24 minutes. It is 10:24 a.m. Answer for this question is, it is 10:24 a.m. Now, again I am saying, why did I discuss this train topic? It is pretty much similar to this beautiful questions what we have in boats and streams. And I always believe that if you can connect the dots, your learning will be so effective. And you can make understanding of all these problems so beautifully. And this will never be a difficult thing when you see it in the examination hall. That is the reason I always love to connect the dots whenever there is a possibility between the problems. Now see here, what is the question in boats and streams? the distance between AB is 174 kilometers. Now, in my previous train questions, they have not given the distance. We calculated the distance as LCM. In this question, they themselves is giving the distance. Okay, no problem. I am not having any issues because anyway I got the value of distance as 174 directly. So no issues for me. Now, what is that they are saying? Two boats start moving towards each other at the same time at point A and point B respectively. It is something like two trains are traveling in the opposite direction towards each other. Instead of trains, it is given as boats. So no issues with this statement also. Now, one in upstream and the other is in downstream. Now, one is upstream and the other in downstream. So that is the main point here. Okay, because this is a boat's topic and the boat will always have upstream speed and downstream speed concept, unlike trains. So one of the boat is traveling in upstream, the other one should definitely be in downstream because the upstream opposite, because they both are in traveling in opposite directions to each other. So definitely if one is in upstream, the other should be in downstream, which is understandable. Now, what is that they have given? If their speed in still water is 9.6 kilometers per hour. So speed of boat in still water, both of them is having the speed of, sorry, not both of them, one of the what do you say, like a boat is having the speed of boat in still water as 9.6 kilometers per hour and the other one is having 19.4 kilometers per hour respectively. So we know the speed of the first boat in still water as 9.6 kilometers per hour. Let me not write the entire thing as of now. Let me just write 9.6 and the other one speed of boat in still water is 19.4 kilometers per hour. Then in how much time will they meet? How much time will they meet is exactly similar to what we have discussed in the train. So, in fact, in train, we did not calculate, or we calculated in how much time will they meet. We calculated at 2 hours and 24 minutes. We also calculate what is the time at that point of a time. It is 8 a.m. plus 2 hours 24 minutes, 10:24. But in the boats and streams problem, they are not asking what is the time. They are just asking in how much time will they meet. Now see here. Think a little logically. Can I say that in train's problem, I was in need of speed and in here also I was in need of speed. Why was I requiring speed in train's problem? Because relative speed concept will come when both of them are traveling in the opposite direction. Same thing here also. I have speed of boat in still water, but I don't know what is the speed of the first boat totally, right? The speed of first boat totally. So speed is nothing but, can I say that it is nothing but, so this is, suppose for example, assume that the first boat is traveling in upstream. The second boat should definitely would have traveled in downstream speed, right? So can I say that if A is traveling in upstream, upstream speed is nothing but B minus W. B is given in the question as 9.6 minus W. We don't know W value. Similarly, second boat is traveling in downstream speed. It is B plus W. It is 19.4 given in the question plus W. So these are the speeds. But they are asking you the time. Time is nothing but distance by speed. Distance is given in the question as 174. Then what are you worrying about? Substitute as 174 and divided by speed. Whenever two boats are traveling in opposite direction, it is the sum of the speeds once again. So it is 9.6. Let me write it for your understanding. 9.6 minus W plus 19.4 plus W. Minus W and plus W cancels. So it is 174 divided by 19 plus 9 is 28. 0.6 plus 0.4 is 1. 28 plus 1 is 29. 174 divided by 29. Answer for this question should be 6 hours. In how much time will they meet is the question. They both will meet after 6 hours from their starting point. I hope the question is very, very beautifully corrected and well beautifully understood by you people by connecting the dots with the previous question what we have discussed in trains. Now, I will not stop at this point because I always love to extend the concept. You might be wondering, like the way you have wondered when I took the trains problem, sir, you have taken both the trains starting at the same time. What if both the trains are starting at different times? Suppose, for example, sir, I have one of the train starting at 5 a.m. here, and I have another time. This assume that this is reaching at somewhere around 9 a.m. I have another train starting at 7 a.m. sir. This is reaching somewhere at around 10:30 a.m. for example. So let me take it as 7 to 10:30 a.m. So for example, let me take different letters here, P and Q. A train is starting at P, reaching Q, starting at 5 a.m., reaching at 9 a.m. Another train at Q is starting at 7 a.m., reaching at 10:30 a.m. At what time will they meet is the question. So exactly same like my previous concept, what I taught it trains. Then why are you teaching once again? Because this next question of boats and stream is little related to this. I am saying again, I want to connect the dots. Now see here, same logic. Time taken from P to Q. It is at 5 o'clock to 9 o'clock, 4 hours. Time taken from Q to P. It is 7 to 10:30. It is 3.5 hours, which is 7 by 2 hours. Distance is constant. I will assume the distance as LCM of the given time. LCM of 4, 7 by 2. It is nothing but 4 and 7. LCM is 28. HCF of 1 and 2 is 1. So distance is 28 kilometers. I am assuming the distance between P and Q at 28 kilometers. So if I take this at 28 kilometers, speed of first train P, it is distance 28 divided by time 4 hours. 28 divided by 4 is 7 kilometers per hour. Speed of second train Q, it is nothing but 28 divided by 7 by 2. It is nothing but how much? It will be 8 kilometers per hour. Now think little logically, you will understand it much more better. Can I say that first train is starting at 5 o'clock itself, whereas second train is a little bit lazy. It is starting at 7 o'clock. So from 5 o'clock to 7 o'clock, only the first train P is traveling alone, right? First train P is traveling alone. So 5 o'clock to 7 o'clock means 2 hours. First train capacity is in 1 hour it can cover 7 kilometers. In 2 hours it is able to cover 14 kilometers. So out of 28, 14 is already completed. Remaining 14 kilometers need to be traveled by both the trains P and Q together. And they are asking you time. Time is equal to distance by speed. So distance that both need to travel is remaining 14. Speed when they are traveling in opposite direction is 7 plus 8. 7 plus 8 is 15. So 14 by 15 hours is the time. So it is 14 by 15 into 60 minutes. So 15 into 1, 15 into 4. 14 into 4 is 56 minutes. That means the question is at what time will they meet? So from 7 o'clock, this is the point. This is the point where I am highlighting in red color right now, where both of them are starting at 7 o'clock. That means train P is continuing from 7 o'clock, train Q is starting at 7 o'clock. From 7 o'clock, they will travel for another 56 minutes and then they will reach or meet. So answer is 7 o'clock plus 56 minutes, 7:56 a.m. Answer for this beautiful question is 7:56 a.m. is the meeting time. But why did I discuss this once again? One of the reason is because both of them are starting at different time. But another reason is, again I want to connect the dot between that particular time and what is that trains problem and also this boats and streams problem. See here how beautifully you can solve this. Same question, exactly similar, little bit of differences. I don't say exactly same, little twisting here and there, but the concept is the same. Question says the distance between A and B is 211 kilometers. Let me write it in a diagram. A and B is having a distance of 211 kilometers. That is my first statement. One boat starts moving from point A towards B in downstream at 7:45 a.m. That means first boat is starting at 7:45 a.m. similar to the trains problem what we discussed, and it is downstream, right? It is downstream. Remember this left hand side is downstream, right? I'll just write it as down here. So if this is downstream, definitely this should be upstream. There is no doubt about it. Now next, after 1 hour, another boat starts from point B towards A. Observe carefully in the question, they have not given us upstream, but it is understood for us. After 1 hour means it is at 8:45 a.m. the second train in the second boat in the opposite direction is starting and it's going like this in the upstream direction. At 12:45 p.m. both the boats will meet. Now in the trains problem, what we discussed in that particular problem, we were finding this 12:45 p.m. as our answer. We were finding that value, but in this question that itself is given. That itself is given at some point called as 12:45 p.m. they both will meet. Right now, if the speed of first boat and the second boat is 26 and 18 kilometers per hour respectively in still water, right? It is in still water. First boat in still water, it is 26. Second boat in still water, it is 18. Find the speed of water current. Now, can I say that I need the speed of first boat completely, not in still water. When it is traveling along the direction of the stream in downstream, I need the speed of boat. That means downstream speed is B plus W. B is nothing but 26 plus W. And W is nothing but what we are finding. Please see the question. Find the speed of a current. That is the question. That is what we are finding. Next. Here it is upstream. Upstream speed is B minus W. It is 18 minus W. I hope you are understanding. Now, we know that distance is equal to speed into time, right? Distance is equal to speed into time. And we know that whenever two bodies are traveling in the opposite direction, speed is nothing but the sum. So it is 26 plus W plus 18 minus W. And time. What is the time? See, think little logically. We are all very, very matured enough to understand these things right now. Can I say that how much time is required right now? So can I say that this speed is calculated as relative speed only after the second train starts at 8:45. That means from 8:45 they both traveled for some time and they met at 12:45. From 8:45 to 12:45, how much time they have traveled? They have traveled for 4 hours. I hope you are understanding. W and minus W cancels. 26 plus 18 is 44. 44 into 4 is 176 kilometers. That means, can I say that the distance is 176 kilometers from somewhere to somewhere. So for example, from here to here, it is total distance of 176 kilometers that is definitely traveled. Now, little bit of extra understanding is what is required. Now, think a little logically once again. So can I say that? So this is given as first train or first boat is starting at 7:45 a.m. Second boat is starting at 8:45 a.m. That means from 7:45 a.m. to 8:45 a.m. the first boat is traveling alone. For how much time it is traveling alone? It is traveling alone for a time of 1 hour. So it is traveling for 1 hour. And I can also say that it is traveling for 1 hour and this distance is 176 kilometers by the time they met. So that means this is the meeting point, this should not be the meeting point here. So this should be 12:45, right? So when both the trains are traveling, both the boats are traveling rather, it is 176 kilometers that both of them have traveled. Out of 211, 176 is done. Remaining is 35 kilometers. I hope you are getting. Remaining is 35. And this 35 kilometers was traveled by first boat A alone and that too for 1 hour. In 1 hour it has traveled 35 kilometers. In 1 hour it has traveled 35 kilometers means so total speed is 35 kilometers per hour of first boat. I hope you are understanding. What is the meaning of 35 kilometers per hour? 35 kilometers per hour means in 1 hour it has traveled 35 kilometers. From 7:45 to 8:45 it has traveled alone and it has traveled alone for 1 hour and it has traveled for 35 kilometers. How did we get this 35? We came to know that when both of them are traveling, it was 176 kilometers that is traveled by both that boat together. So remaining out of 211, 176 together. remaining 35 should be A alone. That means boat A alone. So speed of boat is 35 kilometers per hour, and it is also known that it is 26 plus W should become this 35. So 26 plus which number is 35? 26 plus 9 is only 35. So W value is 9, and that is what we are required in this question. Speed of current. Answer for this question is 9 kilometers per hour. These are all some exceptional way of understanding and solving the question. I hope you are all getting the concept of what we are discussing right now. I hope everyone is very clear with all the problems. I think some 7 or 8 problems with what I have discussed, along with couple of questions in trains also. You are all very clear in understanding these 8 questions what we have discussed till now is what I believe. Next, question number 9. This is slightly an easy question compared to the previous question. The ratio of speed of motor boat to that of speed of current of water is 55:7. That means speed of boat and speed of water, it is given as 55:7. Okay, this is also a very good question. In fact, the boat goes along with the current in 6 hours and 24 minutes. Along with the current, always remember, along with the current is nothing but downstream value. Against the current is nothing but upstream value. That means time taken to travel downstream is 6 hours and 24 minutes. So you need to convert it. In fact, so 6 hours and 24 minutes is 1 hour is 60 minutes, 6 hours is 360 minutes plus 24 minutes. It is 384 minutes. So downstream time is given in the question as 384 minutes. Next, it will come back in how many minutes or how many hours and minutes, in fact, as per the answer options. Now that means they are ideally asking you to find the upstream time. Now think little logically. We know that boat and water, it is given in the question as boat and water current are in the ratio 55:7. Now can I say that downstream speed and upstream speed? So downstream, suppose let me write it like this for your better understanding. Downstream speed, it is nothing but B plus W. 55 plus 7 is 62. Upstream speed is B minus W. 55 minus 7 is 48. Downstream speed and upstream speed ratio is 62:48. It is 31:24. And the distance from going from one point to another point and coming back in the reverse direction, distance is constant. If the distance is constant, time ratio is nothing but the reverse of speed ratio. So time is nothing but the reverse ratio. It is 24:31. So can I say that downstream time is 24 minutes, upstream time is 31 minutes according to the ratio. But question says downstream time is not 24 minutes according to question. Downstream time is 384 minutes. So 24 should become 384. 24 into 1 is 24. Remaining is 14. 24 into 60 is 144. So 24 into 16 is 384 minutes. 31 also multiply by 16 to get the upstream time. I hope you are all understanding and enjoying this beautiful concept of ratios. 31 into 16 is, it should be 496 minutes. Convert it to hours concept. 496 is 8 hours. 8 hours is nothing but 480 minutes plus another 16 minutes to make it as 496 minutes. Answer is option C. These are all beautifully, it can be solved by using the concept of ratios. Try to avoid the variables concept to solve all these kind of questions, and I am sure that you will enjoy the concept of ratios if you keep on solving more and more questions. Next, speed of motor boat in still water is 45 kilometers per hour. Let me write down every data that is given. Speed of boat is 45 kilometers per hour. If the motor boat travels 80 kilometers along the stream is nothing but downstream. Please remember, downstream speed. Downstream speed is what I am trying to find right now. So downstream speed. So see here, what is given? If the motor boat travels 80 kilometers along the stream in 1 hour 20 minutes. 1 hour 20 minutes is nothing but 80 minutes. So that means 80 kilometers is traveled in 80 minutes. But per hour is nothing but 60 minutes. In 80 minutes it is 80 kilometers. in 60 minutes it is 60 kilometers. Simple. So that means downstream speed is 60 kilometers per hour. Very simple way of calculating, right? Downstream speed is 60 kilometers per hour. Now think logically. Downstream speed is 60. Speed of boat in still water is 45. So speed of water current should be remaining 15 because D is nothing but B plus W. So we know D, we know B. So W is nothing but remaining 15. So W is nothing but 15 kilometers per hour. Now what is that they are asking? Find the time taken by the boat to cover the same distance against the stream. Time taken is the question. That means generally they are asking you upstream time. Upstream time. First of all, to find upstream time, let us calculate upstream speed. Upstream speed is nothing but B minus W. B is 45, W is 15. 45 minus 15 is 30 kilometers per hour. So what is that which is holding you to find the time right now? It's so simple. Upstream time is nothing but total distance divided by upstream speed. Upstream speed is 30. Distance is given in the question as 80 kilometers. Same distance also is mentioned in the question. So it is 80 is the distance. So it is 8 by 3 hours. 8 by 3 hours is nothing but it is a mixed fraction. If I convert, it is 2 by 3 hours. So it is 2 hours. 2 by 3 hours. 1 by 3 hours is 20 minutes. 2 by 3 hours is 40 minutes. It is 2 hours and 40 minutes. Answer for this question is 2 hours and 40 minutes is the time taken to travel by the same boat if it is traveling in the against the stream to cover the same distance. I hope you are very clear with the first 10 beautiful questions along with the concept what I discussed initially. So next question, very beautiful question. See this question. A man can row 45 kilometers downstream. So let us write every information what is being given. A man can row 45 kilometers downstream and return in a total of 9 hours. Right? So they have clearly given a man can row 45 kilometers downstream and he can return in a total of 9 hours. Next, if the speed of boat in still water is 1 by 3 times the speed of current. So the speed of boat in still water, it is given as 1 by 3 times the speed of current. Speed of boat in still water is 1 by 3 is nothing but 7 by 3. 7 by 3 times of speed of water current. So it is W. So in fact, if I write it in terms of a ratio, B is to W is nothing but 7 is to 3. Now this is the ratio of speed. This is the speed ratio. So speed ratio is 7:3 for boat and water. So we can, from this we can find it. So the downstream speed and the upstream speed. Downstream speed is B plus W, it is 7 plus 3. Upstream speed is B minus W, it is 7 minus 3, which is 4. So it is 5:2. But whatever the downstream speed and upstream speed ratio, we got it as 5:2. We can convert into downstream time and upstream time ratio because the speed and time are inversely proportional provided the distance is constant. In this question, nothing is mentioned. So by default, distance is constant. So that's the reason. Speed ratio is 5:2. Time ratio will be 2:5. Right? I hope till this point it is clear. Now, what is the question? Find the speed of current. That means basically W value is what we are trying to find in this question. Now see here. Can I say that a man can row 45 kilometers downstream and return in a total of 9 hours? In the question it is given as 9 hours. But according to ratio it is 5 plus 2, 7 hours. According to the question it is 9 hours. So 7 should become 9. Multiply by 9 by 7. Here also multiply by 9 by 7. So 2 into 9 by 7 is nothing but 18 by 7. And similarly 5 into 9 by 7 is nothing but it is 45 by 7. So 45 by 7 is the upstream time. 18 by 7 is the downstream time. So we know the time of downstream and upstream. We also know the what else we know? So we also know we need to basically find the exact value of downstream speed and upstream speed in this case. So and it is given that a man can row 45 kilometers downstream. So that means downstream speed is nothing but distance is 45 kilometers divided by time. Distance by time, speed is equal to distance by time. So time is nothing but 18 by 7. That by 7 will go above. So it is 9 into 2, it is 9 into 5. So it is 35 divided by 2 is the downstream speed and upstream speed is 45 is the distance. Upstream time is nothing but 45 by 7, which we have calculated in the previous screen. You can see here 45 by 7. So if I simplify, this will be 7 kilometers per hour. Now we know the downstream speed and upstream speed. What is the question? You need to find the water current speed. So W is nothing but D minus U by 2. D is nothing but 35 by 2, which is 17.5, minus U is nothing but 7. 17.5 minus 7 is 10.7, 10.5. 10.5 divided by 2. It is 5.25. 5.25 is nothing but 1 by 4 kilometers per hour. Very, very easy question. Answer for this question is 1 by 4 kilometers per hour. I hope the first question or the 11th question in this particular topic is very, very clear for all the students. Next. Question number 12. Keep on listening. You will learn some beautiful techniques here. Keep on listening to all the problems, whatever we discuss. Question number 12. See here, sir. Question number 12 says, a motor boat in still water travels at a speed of 36 kilometers per hour. So B value is given in the question as 36 kilometers per hour. It goes 56 kilometers upstream in 1 hour 45 minutes. So upstream speed is, distance is 56. Time is nothing but 1 hour 45 minutes. It is 1 3 by 4. It is 56 divided by 4. 1 3 by 4 is nothing but 7 by 4. So 7 by 4 will go above. 7 into 8 is 56. 8 into 4 is 32 kilometers per hour is the upstream speed. What is the question? The time taken by it to cover the same distance is constant down the stream. So basically they are asking you the downstream time, right? Downstream time, and the distance is also same. That means distance is 56 kilometers. That is for sure, no doubt about it. So probably we can just write it like this. Downstream time is nothing but downstream distance is 56 divided by downstream speed. Downstream speed we don't know. That is what we need to calculate. Now can I say that upstream speed is nothing but B minus W. B value is nothing but 36. Upstream speed is 32. So it is 32 is equal to 36 minus something. So that something will be 4. So we know the W value as 4. Why are we calculating W? Because we basically need D value. D is nothing but downstream speed is B plus W. B value is already known as 36. W is 4. So D value is 40. So basically downstream time is 56 divided by 40, which is nothing but 7 divided by 5. 7 by 5 hours is nothing but 1 2 by 5 hours. 1 2 by 5 hours is 1 hour. 2 by 5 hour, if you calculate it, 2 by 5 into 60 minutes, it is 24 minutes. So 1 hour 24 minutes should be the answer for this question. But if you are really smart, this is all the smartness which I am telling you right now. If you are really smart, yes, whatever I solved in method 1, I think it is beautiful method. I am not denying that fact, extremely beautiful. But method 2, if you can just look at the answer option for 1 or 2 seconds or probably 5 seconds before starting method 1, I think you will save a lot of time in the examination. See here, what is that they are asking? Time taken to cover the same distance downstream. Downstream time they are asking, and you know that very, very simple way. You know that upstream time is given in the question as 1 hour 45 minutes. The upstream time is already given, and we also know that downstream time, upstream time will always be greater than the downstream time. Agreed, right? If you are traveling in a bike, for example, when you are traveling upside, you will take little more extra time compared to traveling the same route downside. So upstream time is greater than downstream time, or in other words, downstream time is always lesser than upstream time. In the question, upstream time is 1 hour 45 minutes, and they are asking you to find the downstream time. So downstream time should definitely be lesser than 1 hour 45 minutes. 2 hours is greater than 1 hour 45 minutes. 3 hours is greater than 1 hour 45 minutes. 2 hours 21 minutes is greater than 1 hour 45 minutes. There is only one option, option C, 1 hour 24 minutes, which is lesser than 1 hour 45 minutes. It is purely the common sense. There is no usage of pen in this problem if you are really smart and if you are really using your logical skill set to solve the problem rather than just applying some formula based method to solve the problem. I hope question number 12 is very, very clear for all the people who are listening to this class. Next, 13th question. Very, very beautiful question. We will see some extraordinary questions from now onwards. Keep on listening. Extremely important. Many times it has come in the exams also. See here. A boat goes 6 km per hour in still water. So, speed of boat in still water, it is 6 kilometers per hour. But takes 3 times as much time in going the same distance against the current. Very, very important word is against the current. Against the current is nothing but upstream, right? Against the current is nothing but upstream. Along the current is nothing but downstream. So basically the terminologies here are very, very important. Against the current is upstream. That means, can I say that they are saying that the boat goes 6 km per hour in still water, but it will take 3 times as much time in going the same distance against the current. That means if you are traveling against the current in upstream direction, upstream time taken is 3 times more compared to whatever the time taken when you are traveling in still water. That is the meaning of it, right? Upstream, when you are traveling up the road, you are actually taking 3 times more than traveling in the plain road. In a, what do you say, like no up or no down road, it's a plain road. If you are traveling in a plain road, which is a straight road, you will take 3 times lesser time compared to what you are traveling in upper road. That's the meaning of this basically. So from this I can write that upstream time divided by upstream time, upstream time divided by still water time, it is nothing but 3 divided by 1. Now this is time ratio, but the question says it is same distance. So from this I can write the speed ratio as reverse. Upstream speed divided by speed of boat in still water, it is reverse of 3:1, which is 1:3. Now what is the meaning of U is to B is 1:3? Upstream speed is 1. Speed of boat in still water is 3 km per hour. But in the question they have clearly given that speed of boat in still water is 6 km per hour. So 3 should become 6. Multiply by 2. 1 also multiply by 2. 1 into 2 is 2. Upstream speed is 2. Speed of boat in still water is 6. They are asking you to find the speed of current. Speed of current W is nothing but, so we know that upstream speed is nothing but B minus W. So W will be nothing but B minus U. So B is nothing but 6, U is nothing but 2, B minus U is nothing but 4 kilometers per hour. Easily you can calculate by a beautiful concept of ratios. Ratios concept, you can use it and powerfully solve all these problems without using much of equations or variables. Next question. A boat takes 60% more time to cover a certain distance. That means again distance is constant in upstream than downstream. Now first of all, what is the meaning of 60%? 60% is nothing but 60 by 100. 60 by 100 is nothing but 3 by 5. And they are using a word called as more. More is nothing but increase. Now can I say that upstream time taken is 60% more compared to downstream time taken? That is the question. You are traveling up the road, so you are taking 60% more time compared to traveling down the road. That is the meaning of this question or the statement. Very simple. That means, can I say that if I take 5 minutes to travel down the road, 5 minutes or hours, you can directly consider as hours, time taken to travel down the road, downstream time, if it is 5 hours, then upstream time will always be equal to 3 hours more than 5 hours. 3 hours more than 5 hours. 3 hours more than 5 hours is 8 hours. Now, a smart student might ask it out. Sir, how can you be sure that the denominator is downstream time itself? Why cannot be it upstream time? Think logically. If you are taking upstream time as 5, then downstream time will be 3 more than 5, 8. So can the upstream time be lesser than downstream time? No, it is never a possible case. In any scenario, that is not a valid statement. Upstream time can never be lesser than the downstream time. So that is the reason denominator in this case should be downstream time itself. So that means downstream time and upstream time ratio is 5:8. Downstream speed and upstream speed ratio will be reverse of 5:8, which is 8:5. Now we know D value, we know U value in terms of ratio. So find out B and W value in terms terms of ratio. B value is nothing but D plus U by 2. 8 plus 5, which is 13. 13 divided by 2 is B, and W value is D minus U by 2. 8 minus 5 is 3 by 2. But it is in terms of ratios, right? So you can cancel the same denominators. So ratio of B is to W is 13 is to 3. That means 13 is to 3 is the ratio of B is to W. Now read the next statement. Speed of current is given in the question as 9 kilometers per hour. Speed of current according to ratio is 3, but question says 9. 3 is becoming 9. Multiply by 3. This 13 also multiply by 3. So basically can I say that the original value of W is 9 and the original value of B is 39, right? Original value of B is 39. What is the question? In how much time will it cover? In how much time it will cover 504 kilometers in downstream. Downstream time they are asking. Downstream time is nothing but downstream distance of 504 kilometers. And downstream speed is nothing but B plus W. B plus W is nothing but 39 plus 9, which is 48. 504 divided by 48. 48 into 10 is 480. Another 24 is remaining. 48 half of 48 is 24. So it is 10.5 hours. Answer for this question is 10.5 hours, which is option B. I hope you are able to analyze the terms given in the question in terms of percentage also very easily. Don't use any efficiency based questions and other things. Easily you can solve by using this kind of beautiful shortcuts by using ratios. Question number 15. A boat takes 1/4 time in moving a certain distance downstream. Again the distance is constant than upstream. That means a boat takes 1/4 time in moving a certain distance downstream than upstream. That means downstream time is 1/4 of, just 1/4. That means just 25% of whatever the upstream time you have taken. That means if you are taking upstream time as 100 minutes, for example, downstream time will be just 25% of 100 minutes. That means you will just reach in 25 minutes itself if you go down the lane. That's the meaning of it, right? Just an example I told. So convert it to ratio. Downstream time is to upstream time is nothing but 1:4. So distance is constant. So speed ratio will be reverse of time ratio, which will be 4:1. From here same logic, exactly same logic like my previous question. B is to W is D plus U by 2. 4 plus 1 by 2 is 5 by 2. 4 minus 1 by 2 will be 3 by 2. But because it is ratios, you can cancel the 2's. So B is to W is 5:3. Now, I know the value of B is to W as 5:3. What is the question? Question is the speed of boat in still water, that is nothing but 5, is how much percentage more than the speed of current. Now, if you have listened to my percentage class, you can easily understand this. If you have not listened, please listen there once again, or you can just listen to whatever I say right now. Now, whatever comes after more, whatever the word which comes after more should be there in the denominator. What is coming after more? Speed of current is coming in after more. Speed of current is 3 as per the ratio. Put that 3 in the denominator. Now, another thing is, if you are using a word called as than, then the numerator should be the difference between the speeds. Difference is 5 minus 2, 3. Sir, how it is, sir? Why after than it should be in the denominator? Why than? If it is than, the numerator is the difference. Please refer to my percentages class for more clarity, because I do not want to waste percentages. I do not want to take here once again and waste our time. So 2 by 3 is the percentage what they are looking for, and 2 by 3 value is 66.66%. Answer is option B. Next, question number 16. A boat covers a certain distance downstream in 1 hour 48 minutes. Again, its distance is constant. That means downstream time is 1 hour 48 minutes. 60 minutes plus 48 minutes is 160 minutes. Okay. And covers twice the distance upstream in 5 hours 20 minutes. Now think logically. Twice the distance upstream. That means 2 times of upstream distance. 2 times of upstream distance. For example, I'll call it upstream distance as du. For example, the time taken is 5 hours and 20 minutes, which is 320 minutes. But we are not interested in 2 times of upstream distance. We are only interested in 1 time of upstream distance. That means time taken to travel 2 times the distance in upstream, it is 320 minutes. So for 1 time it is 1 way. For 1 way it is half of 320, which will be 160 minutes. So we know the ratio of downstream time is to upstream time in this question also, like our previous questions. So downstream time is to upstream time is 108 is to 160, which can be further simplified by 4. 4 into 27 is 108, 4 into 40 is 160. Now we know the downstream time and upstream time. So speed ratio will be reverse because the distance is constant. It is given in the question as certain distance. So speed ratio will be 40 is to 27. Now same logic once again. We want to find B is to W. B is D plus U by 2. 40 plus 27 by 2, which is 67 by 2, right? 67 by 2. 40 plus 27 by 2 is 67 by 2. Ratio with the W is 40 minus 27 by 2, 13 by 2. And because it is ratio, the denominator 2 can be cancelled out and it is 67 is to 13. Now, what is the next statement? The next statement is, if the speed of current is 5.2 kilometers per hour, that means in the question they have clearly specified that the speed of current is 5.2 kilometers per hour. According to the ratio, the speed of current is 13. According to the question, the speed of current is 5.2. 13 into 4 is 52, but it is 5.2. So 13 into 0.4 is 5.2. That means we came to know that the multiplying factor is how much? It is 5.2. In this question, the multiplying factor is 5.2. So that means all the values you should multiply by, multiplying factor is not 5.2, sir. Multiplying factor is 0.4, right? Multiplying factor is 0.4. So that means you can multiply all the values in this question by the same multiplying factor 0.4. That means the downstream speed is, according to the ratio, downstream speed is B plus W. 67 plus 30, it is 13, it is 80. According to ratio, it is 80. According to the question, how much? Multiply by 0.4. 80 into 0.4 is 32 kilometers per hour. Similarly, upstream speed is nothing but B minus W. 67 minus 13. It is 54. Multiply 54 also by the same multiplying factor 0.4. 54 into 4, it is 216. 54 into 0.4 is 21.6, right? 21.6. What is the question they are asking you? How much time it will take to go 86.4 kilometers downstream and return upstream? So distance is constant as 86.4 and they are asking you to calculate the time. How much time? So total time taken is nothing but downstream distance is 86.4 initially and downstream speed is given, we calculated as 32 plus upstream distance is also once again same distance of 86.4 and upstream speed we calculated at 21.6. If you further simplify this, 21.6 and 86.4, 21 into 4 is 84. 0.6 into 4 is 2.4. It is 86.4. So it will go exactly 4 times. Similarly, 8 into 4 is 32. And if you further simplify, 8 into 1 is 8 and 8 into 64 is remaining, 8 into 08, it is 64. So because there is a decimal point, it is 10.8. So further you can simplify because this is 4 into 1, 4 into 2.7. So final time taken is 2.7 hours plus 4 hours. It is 6.7 hours. So 6.7 hours is 6 hours and 0.7. 0.7 is 7 by 10 hours. 7 by 10 into 60. 10 into 1, 10 into 6. 7 into 6 is 42 minutes. 6 hours 42 minutes should be the answer. And if you see the last 3 questions, including this question, every question we are using a beautiful same concept where time ratio is given or we calculated it and we calculate the speed ratio. From the speed ratio, we calculate the B and W ratio. From the B and W ratio, we calculate whatever the according values they are asking you in the question. Simple. Don't get intermediate distracted or don't get carried over by the question thinking that it's a difficult question. These are actually very, very easy question if you know how to solve them in the most easiest way possible. Next, question number 17. Question number 17. The speed of boat in still water is 75% more than the speed of current. That means 75% is 3 by 4. More is nothing but increase. So can I say that if the water speed is 4 kilometers per hour, speed of boat in still water will be 3 more than 4. 3 more than 4 is 7 kilometers per hour. You might get a doubt once again. Why should we consider this 4 as water itself? Why not we consider boat? Because we already know that speed of boat in still water value is always greater than speed of water. So definitely denominator value should be 4 should be water, and 3 more than 4, 7 should be boat itself. So no confusions at all. So we directly came to know the value of B is to W in this question. In all the previous 3-4 questions, we were calculating B is to W from the speeds. In this question, it was direct straightforward. So B is to W is 7 is to 4. D is to U. Downstream and upstream speed ratio is 7 plus 4 is 11. 7 minus 4 is 3. I hope till this point it is super clear for you people. Next, what is the next question? If a boat takes a total of 8 hours to cover 132 kilometers distance in downstream and 60 kilometers in upstream. Now, please be very, very careful in this case. We calculated the downstream speed and upstream speed ratio. You cannot just write it as the speed ratio is 11 is to 3. Time ratio will be reverse 3 is to 11. No, you cannot write it in this question. Why we cannot write? Because the distance downstream is 132 and the distance upstream is only 60 kilometers. So the distance is not constant. Only when the distance is constant, speed ratio and time ratio are inversely proportional, not when the distance is not constant. I hope you are getting. So the total 8 hours is given and the downstream distance and upstream distance are also given. Then you need to calculate speed of boat in upstream is how much less than the speed of downstream. This is the question. Now see here. It's very simple. It's very, very simple. Can I say that time is equal to distance by speed, right? Time is equal to distance by speed. So can I also say that if I use the same notation here, so time, so total time taken is given in the question as how much? It is given in the question as 8 hours. So this 8 hours is totally upstream, downstream and upstream combined together. So downstream distance is given in the question as 132 and downstream speed is given in the question as how much? So okay, downstream distance is 132 only, right? Yes, it is 132 itself. Downstream speed is given in the question as 11. So we can call it as 11k and 3k for time being using a variable called as k. I will also eliminate that method of variables in another 2 minutes or 3 minutes in method 2. Do not worry about it. Plus upstream time is, upstream distance is 60, upstream speed is 3k. If I simplify, 11 into 12 is 132, 3 into 20. So this is nothing but 8 is equal to 32 divided by k. 8 into 1, 8 into 4. So basically k value will be equal to 4. K value is 4 is nothing but this is 44 is the downstream speed and 12 is the upstream speed, right? 44 is the downstream speed and 12 is the upstream speed. What is that they are asking? Speed of boat in upstream. That means upstream speed is how much less than downstream speed. Upstream speed is how much less than downstream speed means they are basically asking you the difference between upstream speed and downstream speed. Upstream speed and downstream speed difference is 44 minus 12. It is 32 kilometers per hour, which is option D. Right, which is option D. Now you might be wondering, no sir, this method involves a variable called as k. Can you please teach me a method which does not involve a variable called as k, without any variable called as k or something like that? Can you please teach some other method? Yes, absolutely. Method 2. Please see here, method 2. Same, almost similar, but slightly different in the way we think. B is to W is already known as 7 is to 4. So B is, let me write down the data which is already known. B is to W is 7 is to 4. So D is to U will be 11 is to 3. That also we came to know. D is to U will be 11 is to 3. Now, In the question it is given that total time is 8 hours. According to question it is 8 hours. Let us find according to ratio. Time taken downstream is distance is 132 divided by speed is 11. Let us not take it as 11k. Let us take it as 11 itself. Let us assume according to ratio as 11. So 132 by 11 is 12 hours downstream time. Time taken upstream. Upstream time is 60 is the distance. 3 hours is according to ratio upstream speed. So 60 by 3 is 20 hours. So according to ratio, you have substituted as per the ratio as 11. You have substituted as per the ratio as 3. According to ratio, total time taken is how much? According to ratio, total time taken is it is 12 hours and 20 hours. It is nothing but 32 hours. But the question says it is not 32 hours, it is 8 hours. So 32 divided by 4 is 8. Now what is that they are asking you in the question? They are asking you in the question the difference between D and U. You can check it out if you want. The speed of boat in upstream. Upstream speed is how much less than downstream speed. If you want to know how much less or how much more, you need to always take the difference. According to the ratio, the difference between D and U is 11 minus 3. 11 minus 3 is 8. So many people will make a mistake here. They will also divide 8 also by 4 and they will write it as 2 kilometers per hour. Unfortunately 2 is anyway not there in the answer options also. But it is not divided by 4 here, because think logically. This is a time operation. This is speed operation. Time operation and speed operation are always reverse of each other. I am not saying inversely proportional in this question. In this question, they are not exactly inversely proportional because the distance is not constant. Upstream is different distance, downstream is distance is different. I agree with that. But anyway, whether the difference is, whether the distance is the same or distance is not same, time and speed are always reverses of each other, right? They are reverses. May not be in terms of ratio, but they are reverse parameter. If you are using the division parameter for time, then you should use the reverse parameter, that is multiplication for speed. So 8 into 4 is 32 kilometers per hour should be the answer. I hope you are getting the logic, you understood the concept. So please remember, if you are just dividing time by 4, does not mean that speed also should be divided by 4. Speed and time are always reverse parameters. So reverse parameter of division only should be applied for speed here. That is multiplication. So don't get confused. Or if you are getting confused by method 2, that is the reason I taught you method 1 also, that is by using variables. So it's completely up to you. I suggest you not to go by variable method, but it's completely up to you, and I believe that method 2 is also not that difficult, sir. Next, question number 18. The speed of boat in still water is 6 kilometers per hour more than the speed of current. Now something like Ajay is 6 marks. Ajay is 6 marks more than. Same like that, I am writing a statement. Ajay is 6 marks more than. Ajay is getting 6 marks more than Sujay, for example. That means, what is the meaning of Ajay got 6 marks more than Sujay? That means that marks difference between Ajay and Sujay is how much? It is 6 marks. Similarly, speed of boat in still water is 6 kilometers per hour more than speed of water current. Means the difference in the speed between boat and water is 6 kilometers per hour. Simple, sir. Very, very simple. But we already know that B minus W is nothing but what? It is upstream speed. B minus W is upstream speed. So indirectly in this question they are giving you the value of upstream speed as 6 kilometers per hour. Beautiful. Next, what is that we understood? What is the next thing that we can conclude from here? Now see here. If a boat takes a total of 8 hours, totally it is taking 8 hours to cover 44 kilometers downstream and 36 kilometers upstream. Again, remember, this is like a previous question where downstream and upstream distances are different. So 44 kilometers downstream and 36 kilometers upstream. Now think logically, they are saying that the distance traveled upstream is 36 kilometers. In 1 hour, it will cover 6 kilometers upstream. Upstream speed is 6 kilometers per hour. The meaning is, in 1 hour, it will cover 6 kilometers. But the total distance covered upstream is 36. So, total time taken upstream is, in 1 hour 6 to cover 36 kilometers. Upstream time is 6 hours. I hope the concept is clear. Upstream time is 6 hours. Beautiful. But it also says the total time taken to cover is 8 hours. Upstream time itself is 6 hours. That means downstream time should be remaining 2 hours, so that the total will become 6 plus 2, 8 hours. Now, can I say that downstream time is 2 hours and downstream distance is 44 kilometers, which is given in the question? That means in 2 hours, in total of 2 hours, I covered a distance of 44 kilometers. In total of 2 hours, I covered a distance of 44 kilometers. That means in 1 hour, I will cover how much? 22. In 2 hours, 44 means in 1 hour, how much, sir? 22 kilometers. So downstream speed is 22 kilometers. These are all very, very logical, common sense question. With common sense, you can solve it without using pen. Now, downstream speed is 22 kilometers per hour. What is the question? Find the speed of boat in still water. Speed of boat in still water is, it is d plus u by 2. D value is 22, u value is 6, 22 plus 6 by 2, 28 by 2. Answer is 14 kilometers per hour. Beautiful way of, common sense way of solving the problem.